Just briefly, the agenda. I'm going to touch on the applicable system drives and control systems that are required to implement the ability drives performance. It is not for all system drives, so I'll go over that really quickly. And then I'll hand it over to John, and he'll, as I said, he'll give you a nice overview of the ability drives performance solution. Just wanted to clarify about our ability digital services in general. So the drives performance is the first module that we're rolling out, but there are several other modules coming that plug into the ability infrastructure. So, once that ability infrastructure is in place, we'll be introducing QCS connected performance, loop performance, virtual sensors, sheet break analytics, grade change performance, and there's others coming as well. So that ability platform, once it's in place, we have all these different service modules that we can plug in. And then here, as I mentioned, there are certain drives families and control systems that need to be in place to implement drives performance. And those drives families are the ACS 880 and ACS 800. I do want to make clear that drives performance is for systems drives. It is not applicable to standalone drives. Sometimes those are called process drives. We do have some service options for those, but for this ability drives digital solution, it is for system drives only. And then the system 8XA control is a requirement as well. And hopefully this is relevant to everyone on the call. Our objective for invitations to this Tech Talk were customers that have these in place. So hopefully everybody's already there. And that's it for my opening. I'm going to hand it over to John.
Hello, everyone. So I'll spend a few minutes here going over what I consider to be some of the main or most important features of the solution. Don't have time to go through everything today, but what I'll focus on during these few minutes are these four main benefits. One is around increasing the throughput of the paper machine. And basically what the solution can help to do is, one, it monitors the health of the drives and provides things like predictive alerts. And I'll go into that in just a couple of minutes and how the solution helps in that side of things. It also helps to limit sheet breaks. And one of the ways it helps to do that is through monitoring the performance of the control itself. So the speed control or the tension control or the control between the sections. And this is not, you're probably all familiar. I mean, drive systems are very complex. And in order to do something like this, it really takes the ability to monitor down in the millisecond range in order to really determine if the controls are doing what they should be and need to be doing. And that's what the solution does, is it does collect information down at the millisecond range and actually is performing online analytics of that millisecond information. And I'll talk about that a little bit too here in a few minutes. The other way it helps to limit sheet breaks is through efficient root cause analysis. So the information is there again down in the millisecond range, and I'll show how it's easy to drill down from a high level down to the specific information for a specific sheet break to perform effective root cause analysis. And then the other thing I'll touch upon is how the solution can help on the quality side. Things like helping to identify if things like roll slippage is occurring, or if draws aren't being maintained effectively at the right targets. So these are some of the things I'll focus on. Again, this isn't everything that's in the solution, but these I figured would be the most interesting to spend in the next few minutes. And to start with, then, what is it? What does it look like? I just spend just a minute on the architecture. So on the right-hand side here, depicting the drives of a systems drive. And basically what the solution is doing is it's pulling information, and it's a lot of information that it's pulling up into the data collector. So this is information around the drives, like the health of the drives, the currents and the voltages and the temperatures and motor temperatures and things like that. but it's also pulling in the high speed data, which is necessary to really to be able to understand the performance of things like the tension controls and the power loading and the speed control and so forth. So it's pulling all this information in, and then as I had suggested earlier, there are applications that are running against this data online and analyzing to identify if there are any potential issues with, the health of the drives or the control of the drives. And all of this information then is made available through very easy to use dashboards to either you as a user or to ABB subject matter experts as well. And in summary, then over on the left, what it enables is the optimization, the evaluation of the drive health, the speed and tension control performance, the load share, the draw performance, alarms and prioritizing of the alarms. So it's pulling in the alarms, and it's easy to view the alarms and set alarm limits and predictive alerts. And then, as I mentioned, the better root cause analysis. So this is an example of what I term an overview display. There's a lot of information here, and I was going to focus in on 4 main areas. One are the alarm and the events. So I'm pointing here, there's an icon. I know it's kind of small here, but this icon will directly lead to very important and detailed information about alarms and events. And I'll give you an example of that here in a minute. This upper part of the display is all about equipment health. In the overview, it's a very high level. This donut actually there reflects the different drives. If all of the drives weren't healthy, there would either be a yellow or red mark here on one of these donuts. And again, I'll show you how an example how from here, if you wanted to look into the health of the drives, you just click a button and then you drive down into the details. I'll go into that too in a minute. On the bottom part of this overview display is the information, high level again, about the controls. So the speeds, the tensions, the load shares. And once again, you can see here's a couple of these are highlighted in red. And if you wanted to look into that in more detail, you just simply click on what's of interest and you'll go right to it. And again, I'll show an example of that. And then finally, on the sheet brake side of things, right in the center here is the overview information of sheet brakes. And so it gives you an idea of how many sheet brakes, what section of the machine is having the most sheet brakes. And again, up here, and you can't see it, but up here is the time display, and this is selectable. It can be 30 days or it could be today, week, whatever you want to see, and then you see an overview of that particular time frame, and you can change this, when you're on this display. So this provides again the high level information, and now I'll give you some examples of drilling down, and we'll start with alarms and an example of drilling down into that. So imagine you clicking on that button, and what you come to then, you come to this dashboard, and this dashboard can be providing information for a number of different types of things here, including the IGBT temperatures, the inverter control board temperatures, the torque, the voltage, the load share performance, motor temperature, speed performance, tension performance. And it gives here, in this case, giving an example of the IGBT temperatures. So you can, start to get an idea from just a click. You can get down to information to understand over a last period of time. And again, you probably can't see this, but it says 30 days here. So you can see over a period of time, are any of the drives or the temperatures, the IGBT temperatures of any of the drives showing any concerns. And this is, well, the red line up here on this particular display is the upper limit for each of the drives. Now, it doesn't have to be a simple limit. These alarms are configurable, condition-based. There are alarms set up in the solution which look at not only the temperature limit, but the rate of change of temperature. So in other words, how close is it to the limit? How fast is that temperature changing and getting closer to that limit? So you can really start to create condition-based alarms that provides you with an alert when you really want to know about it, but you don't get really limited on the number of false alerts. So if I keep going here on to the next display, so this is an example of the drive health display. So a number of different things here showing the current value. So for each drive, where my cursor is, you can select whatever drive you want to look at. And then for each drive, you get the current values in this section, which, things like the temperatures and the voltages and, on the motor side of things, the speed and the torque and the current. So you can see the exact value, but then down below, you can see the trends as well. And again, you can look at the current, or you can look back into time for that particular drive, and you get a summary of that drive and all of the important information for that drive. And if I go on then to give an example of the controls. So I mentioned before, if you remember on the overview display on the bottom part of it, it gave high level information on whether the speed control or the tension or the load share was performing. So here I'm showing, if you clicked on the button to go to the more detail of the load share, what you get is this dashboard. And what I'm showing in the top panel here, all these dots, these are actual calculations based on the millisecond data to show whether or not the correlation or basically the load sharing between the sections is good or not for that specific time. And these are broken down into 1-minute segments. So basically, the higher it is, the better it is. The better the load share control is. As it gets lower, the bottom limit here of -0.5 is what's typically considered to be a problem. So one can very quickly see, like, for example, for load share, and this is similar to the other control displays as well, one can start to see, are there some issues with the load share? And, for example, say this first load dot was a problem. You can then look down into things that will impact it, the different motor torques related to those two sections, and then down even below is the speed. And if you wanted to blow that up, all you need to do is shade in the area right around this dot, and it will blow up into, and you'll see a large display of just that time period. So you can drill down very quickly into the details. Off to the right here as well, then it gives you for each one of these dots that I mentioned, if there are any periods of time where the load share was not in what was considered to be the acceptable range, you can immediately see that. And again, you can click on it and then get down to that detailed information, understand for a particular event what was happening and why was it not where it should be. So it's a very effective way to start to drill down into the control performance, something that really has never been available to have this type of online analytics to detect that in an automated way. In the past, it was always if you were fortunate enough to have a high-speed data logger, an expert would need to drill down into it and spend quite a lot of time trying to diagnose that. And here, the information is provided at a high level, which leads you to where to dive down into, and then you can dive down into in the same solution. And then the sheet breaks, I showed in the middle panel of the overview display, and there again, if you click on the link there, you come to this display. And this display is showing a couple of different things. It's showing this what looks like a trend. It's actually showing where sheet breaks occurred. So each one of these is a sheet break, and if it's a thicker line, that means the sheet break was on for a longer period of time, or there was a sheet break for a longer period of time. And then just similar on the other display, it shows you also where the most sheet breaks are happening. And if there was a particular sheet break that you wanted to look at, off to the right is the most current one. So if you want to look at the most current one, or you want to look back at any of these, in the bottom left panel, each one of these sheet breaks is identified, and you can simply click on one of these sheet breaks, and that will bring you to this next display. which shows you the detail now of that sheet break. And again, this is down in the millisecond range for these trends, which is needed to really understand what happened during that sheet break, and if it's anything drive related, or may not be drive related, but the information can give also indications of if there's some other mechanical issue happening as well. So, in this case, in this panel, it's the speeds, and down in the lower panel, it's the torques. And again, as I suggested, you can, where this green shaded area is, or where it ends, is where the sheet break occurred. So in this case, if you wanted to look at, just the couple of seconds before and after, you could just shade in that area, and you would just see that information on the display. So you can see, a few seconds before and a few seconds afterward, and really start to understand what happened first and what happened when, and to understand, was there something happened with the drive controls, or does it look like the drive controls were impacted by something on the machine itself? So again, a very, very effective way to drill down into all of this information, starting with the higher level analytics and drilling right down to what you want to see. So then the predictive alerts, which I mentioned before. So I've covered mostly how it's easy to use the information, how the system's providing information that allows one to find what they're looking for very easily and very effectively. But in addition to that, these predictive alerts are part of the solution as well. So these are configurable alerts, and just showing an example here. In this particular example is around the torque. And in this particular case, the torque went below a certain limit. And when it went below that limit for a certain period of time, and over here, it's kind of hard to see, there's a red dotted line here. This is when the alarm was actually generated. So in this case, the alarm has been set up that it has to be below a certain limit for a certain period of time. And if that happens, then an alarm will be generated. And this is taken right out of a body of an email. So this is what one would get in the email. It's not just a simple alert. It's providing basically a snapshot of what was happening, so you get immediate information of what's going on. And then this orange button down here, view your alert rules. If you click on that, it leads you actually directly to the online dashboard and the online information. So you can immediately, if it's something that one needs to start to look into, that's urgent, you can immediately start to do that in a very easy way. And then going to the alerts page, you can also go and see, if other alerts are occurring or have been occurring over time. So this has been something that's been very helpful and useful, something that's been talked about for a long time, and getting predictive alerts without getting false alarms. And the other thing that I'll just comment on here is, with the way that we approach this with the online system and being able to monitor this, we're able to fine tune these alerts to not get false alerts, because every drive system, every machine is going to be a little bit different. So it's difficult to just have a canned approach to this. But with the way that we approach it, we can fine tune these, and then when you get an alert, it's going to be more relevant. So I guess I'll just sum up then, the three key benefits of the solution. The productivity side, which I mentioned, which is, around helping to ensure that the controls, the drive's controls, are performing as they need to be in order for the runnability of the machine. The availability, monitoring different aspects of each of the drives, in the health of them, to ensure that if something does happen, you can diagnose it quickly, but even more importantly, to understand if something isn't healthy on the drive, a temperature isn't healthy, or it's running high from a current point of view. And then the quality, as I mentioned before as well, the tension controls, the draws, and the roll slippages are different examples of how how the system can be used to make sure that the settings are in the right places from a quality point of view. So I know I went through all of this really quickly. We do have a limited amount of time today, so wanted to just give you some highlights, and hopefully this part was useful. But as I think Chris will talk about, we can definitely go into more detail if you want to in the future.